Welcome to my channel, dear students, and all the viewers. And see, today this is the discussion about the application of derivative. Okay, and this is the subject of the rate measure, calculation of the rate measure with the help of derivative. Actually, this is the significance of derivative as the rate measure, rate of changes, and find the approximate value of fourth root of 627 approximate value, and find the approximate value of sin 62 degrees. You know the value of 60 degree, but how can we solve the value of sin 62 degree? And also the logarithm of 10 to the base e. It is logarithm of 10 to the base e is 2.303, and what is the value of that? And also some problem I want to solve this video. Okay, see, first I want to derive the finding the approximation value with the help of limit, actually, which is called the first principle of derivative. From that we are going to derive the approximation formula. Actually, see, you know the first formula, differentiation. This is the first formula, first order derivative formula. This is x tends to 0, x dash, this is x tends to 0 actually, and this is f of x plus h minus f of x by h actually. Okay. Now for calculation of approximation, we don't use here h tends to 0. Just we want to use here like and del. Actually, h is equal to, this is here del x. So we want to apply like that del x and f dash x, and that is equal to f of x plus h, and this is not equal to nearest value. Actually, this is called approximation, and this is f of x plus, and this is del x, x plus and del x, and that is actually f of x plus and del x and f dash x. So this is the formula which I want to use here to finding the value of approximation, that is 1, 2, 3. Okay. So number 1, determine the value of this is question here 6 to 7. So that's why we have a function. Assume the function, this is the fourth root of x here. Okay, now nearest value to 6 to 7, and that is 6 to 5, which is can be findable the fourth root of that is 5 actually. So x here is, that's why x here is 6 to 5, that's why fourth root of 6 to 5 is 5 here. So, and remaining, that is the 2, is called del x actually. Okay, so if we these two added, then we got here 6 to 7. If here is given that the value fourth root of 6 to 4, then we take here 625, but here is 1 is less, so then we can take here del x as a minus 1. Again I repeat, given that the fourth root of 6 to 7, so nearest value, which is fourth root, can be calculated by the fourth root value is easily, that is 6 to 5. So here is a 6 to 7, so del x would be a 2. But fourth root of 6 to 4, then we take here x is 6 to 5, then del x would be here minus 1. Okay, so for this problem, see here, if we differentiate, that is actually x to the power 1 by 4 here. Okay, so 1 by 4 and x to the power 1 by 4 minus 1, and this is 1 by 4, and this is x to the power 3 by 4. Okay, so now f of x means this is 6 to 5, this is here 6 to 5, and del x means this is here 2. So f of This is here 6 to 5. This is del x is here 2, and f dash x, this is the f dash x. So this is here f dashed 6 to 5, implies that this is f of 6 to 7, and this is your queries, and this is equivalent to 6 to 5. This is the function f of x is equal to 4th root of x. So this is the 4th root of 6 to 5, and this is here into 2, and derivative of 6 to 5. Derivative of f dash x, then put the value as 6 to 5. This is here 4, this is the derivative 6 to 5. Then we got here 1 by 4 into 6 to 5 whole to the power 3 by 4. So 4 into 6 to 5 whole to the power 3 by 4 here. And this is equal to, actually this is here 5. This is 2 here. So this is actually 5 to the power 4, and this is 3 by 4. So this is 4 are cancelled. So this is 5 plus 1 by 2 into 5 cube. This is 1, 2, 5. So the technique of approximation, this is here 5. Now want to get here as a 10. This is multiplied by 2. Then we got 10. Again we multiply by 2, like that. Actually this is 2 into 5 into 5 into 5 into 5. So this is 10 for remaining to 5. For we multiply here 4, and then we got here 4. So 5 plus 4 by 10, 10 and 10. This is 1000. So this is 5.5 plus 0.004. This is 5.004 is the approximation value of the 4th root of 627. Okay. And now the another problem is there. See, for question number 2. So we have to find the value of sin 62. So that's why we take a function f of x is equal to sin x. Again I repeat, x is equal to 60 degree, which is known value. So in the previous problem for 1, 4th root of 625, this is the known value, that would be 5. And the added value, if we added 2 to the 60, then we got 62. So that's called the del x. This is 2 degree. Okay, but in the formation like f of 60 plus 2 degree, then 62. This is f of 60. This is 2 degree, and this is f dash 60 degree. Okay, now 2 degree, and this is 2 degree into radian value is given that that is 0.017, 0.034. Okay, this is the radian value. See, in this case, this is f of 60, this is sin 60. This is sin 60 degree. This is actually the value of sin 60 is root 3 by 2, and root 3 by 2 call is the radian value. But here is degree. So radian and degree not to be added to each other. So it needed to finding the value that is radian. This is okay. We want to put the value in place of 2 degree is this. Okay. So this is 0.034, and also f dash. This is f of x is sin x. So derivative is here cos x. So f dash 60, and this is cos 60.